Okay, let's take a look at section 2.3. This is application work, so we're going to look at first converting sentences into algebraic expressions. So one that we are probably going to use quite often is representing some consecutive integers. So the first thing is to let x equal the first integer. So then, if x is the first integer, x plus 1 is the second, and x plus 2 is the third integer. Now, next one says represent 3 unknown consecutive odd integers. So if you think about that, again, you're going to let x equal the first. So if you think of odd integers, how do you get from the first odd integer to the second odd integer? You're going to add 2. So then x plus 2 is the second. And x plus 4 is the third. Okay. Another important one is when you are asked to represent two numbers that sum to 8. And we want to do this in terms of only one variable, so we don't want to say we have an x and a y, we just have x. So to do that, you have x is one of the numbers, then 8 minus x is the other number. So you want to think of that in terms of x and 8 minus x. Next says write an algebraic expression in one variable, just one variable, to represent each verbal expression. So it says two numbers that differ by 12. You could write x and x plus 12, or x and x minus 12. The second one, two consecutive even integers, again, x and x plus 2. C, two investments that total $5,000. So you will have x and 5,000 minus x. D, the length of a rectangle if the width is x meters and the perimeter is equal to 10 meters. So if we have the perimeter is equal to 2 times the length plus 2 times the width, perimeter is equal to 10. Okay, we have a common factor here. We're going to factor that out and divide by 2. So 5 is equal to the length plus the width. If the width is x, then 5 is equal to L plus x. And that's right here. So the length is equal to 5 minus x. So this is 5 minus x. The next is just a list. I'm not going to take the time to read down through that list. It's just translating words into algebra, and you can read over that list. It goes over addition, subtraction, multiplication, and division. So you can read over that list at your convenience. Now we're going to start to take a look at solving problems and using some of those to set up the actual equation. So the first problem is the sum of 3 consecutive integers is 228. So we know that we can let x equal the first, and then x plus 1 equals the second, and then x plus 2 equals the third. So my equation will be x plus 1 plus x plus 2 is equal to 228. Add the like terms, 3x plus 3 equals 228. Subtract the 3 from both sides, so 3x is equal to 225. Divide by 3, so x is equal to 75. So the strategy for solving word problems, you read the problem until you understand the problem, draw a diagram if you can, choose a variable, this is really important, and write down what it represents. That will help you setting up your equation, just understanding what that variable really stands for. Represent any other unknowns in terms of the variables. That means we're not introducing another variable, we're doing it all in one variable. Write an equation that models the situation, solve the equation, and then be sure to check that your answer actually is a solution. So let's go back to this problem and look, and so that means that we have 75 plus 76 plus 77. Add those up and you should get 228. Oh, must not have erased this problem. Okay, we're going to look at several types of word problems. We're going to look at geometric problems. We're going to look at investment problems, mixture problems, blending problems, motion problems. I think that's about it. And there's actually some commission problems. So let's start with the geometry or the geometric problem. It says the length of a rectangular piece of property is 1 foot more. I'm going to add an M there. 1 foot more than twice the width. If the perimeter is 302 feet, find the length. So the first thing you want to do is try to draw a picture of what this looks like. You know, the perimeter is equal to 302 feet. Then it says you have the width. The length is 1 foot more than twice the width. So 2 times the width plus 1 will give me the length. So now I know that the perimeter is equal to 2 times the width plus 2 times the length. So I have 302 is equal to 2w plus 2 times 2w plus 1. Go ahead and do some algebra. I'm going to get 4w plus 2, combine like terms. 302 is equal to 6w plus 2. Subtract the 2, and you will get the width is equal to 50. And then the length would be equal to 101. And when you add that up, you can see that that does in fact make sense. Next is an investment problem. You definitely are going to see this many, many times on some worksheets and actually on the quizzes and tests. So be really good to understand how these problems work. It says Greg invested some money in a certificate of deposit. We're going to call that a CD, certificate of deposit, with an annual yield of 9%. He invested twice as much money in a mutual fund. We'll abbreviate that MF. And the yield on that was 12%. His interest from the 2 investments at the end of the year was $396. So his earnings, that's interest, was $396. How much money was invested in each? So the amount of money invested initially is called the principal. The rate is the interest rate he earned, and the interest is the amount. So if we look at this, he invested some money. We're going to say let X equal the amount invested in the CD. So that's X. The rate of what was invested in the CD was 9%, and therefore the amount of interest earned would be 9.09 times the amount of the principal, so 9% of the principal. The mutual fund, he invested twice as much. We read that in the problem. The rate he's earning on that is 12%, so therefore the interest is 0.12 times 2x, so 12% of the principal investment. His total earnings, so the sum of these two amounts should be $396. So let's set up our equation. It's actually right here. I have 0.09x plus 0.12 times 2x equals 396. So that gives me 0.09x plus 0.24x equals 396. 0.33x equals 396. So therefore x is equal to 1200 and 2x is equal to 2400. So therefore he invested $1,200 in the CD and $2,400 in the mutual fund. Okay. Now we're going to continue on and go over all of the different types of problems, and then over the next 2 days we're actually going to work on word problems in class over the course of the next 2 days, these varying types of word problems. Okay, the next is mixture problems. And in mixture problems you have to think about your total quantity, and are you adding to that or is it remaining the same? And we'll see a couple of different types of these problems. This problem says, how many gallons of milk containing 5% butterfat must be mixed with 90 gallons of 1% milk to obtain 2% milk? So when I look at this, it says, how many gallons of milk containing 5% butterfat? Therefore, my variable, x, is going to be equal to gallons of milk with 5% butterfat. And I like to set up a table for these types of problems. So I have 5%, and then I have 1%. I'm adding 1% to 90 gallons, and I will have, when I'm done, what I will have will be 2%. So the amount of milk with each percent I'll list here. The amount of milk with 5% is x. The amount of milk with 1% is 90 gallons. And when I'm done, I'm going to have x plus 90 gallons. So however many gallons of milk I add to the 90 gallons, that'll be the total quantity I have. Then I have percent of fat. So that's 5%, 1%, and 2%. Remember to convert that to a decimal, so 0.05, 0.01, 0.02. And then I will have the amount, let's see, I'll put it down here, the amount of fat. So when I multiply across, I get 0.05x, 0.01 times 90, and then 0.02 times x plus 90. And my equation is actually, again, right here. So I'm adding 5% times X gallons of butter fat plus what I have, which is 90 gallons of 1% milk. And when I'm finished, I will have X plus 90 gallons of 2% butter fat milk. So this becomes 0.05x plus 0.9 equals 1.8x plus 0.02. Oh, that x isn't there. It's here. Combine like terms, add and subtract. You will then get 0.03x is equal to 0.9 divided by 0.03, and you will get that x is equal to 30 gallons. The next is blending gasoline. It says a dealer has 10,000 gallons of unleaded gasoline. He wants to add just enough ethanol to make the fuel 10% ethanol mixture. How many gallons of ethanol should be added? So again, let X equal gallons of ethanol. And again, I like to set up a table. So I have gasoline, I have ethanol, and then I have my mixture. And then the amount of gas in each of these, the percent of ethanol, and then the amount of ethanol. So gasoline, I have 10,000 gallons. X, remember, is the amount of ethanol that I'll be adding. When I'm done, I will have 10,000 gallons of gas plus the ethanol that I've added. There is no ethanol in unleaded gasoline until the ethanol is added. The ethanol is 100% ethanol. And when I'm finished, my mixture, this part down here, will be 10% ethanol. So when I multiply across, I get 0, x, and then 0.1 times x plus 10,000. So my equation is actually 0. That's the amount of ethanol in unleaded gasoline. Then the amount of ethanol I will add, and that will be equal to 0.1 times x plus 10,000. So we have x is equal to 0.1x plus 1,000. So 0.9x is equal to 1,000. So x is equal to 1,111 gallons and 1/10. And that's the amount of ethanol. 2 more to go, and then you will not have a video tomorrow night. So just 2 more to go today, no video tomorrow. Next one is uniform motion problems. Uniform motion problems involve a constant rate. So let's look at this. Driving Miss Jennifer. Jennifer drove her car for 3 hours in a dust storm. When the skies clear, she increased her speed. So she increased her speed by 30 miles per hour. She drove 4 more hours, and she was completing a 295-mile trip. So how fast was she traveling in the dust storm? So you have 2 conditions here. One is her driving during the dust storm. The other, when it was clear skies. Then, of course, this is a rate times time equals distance problem. So her rate during the dust storm is what we're looking for. And we're going to call that x. And then her rate during clear skies was x plus 30 because she increased her speed by 30 miles per hour. She traveled for 3 hours in the dust storm, 4 hours after the skies cleared. So her distance then, the total distance under both conditions, was 295 miles. So you take the two conditions during the dust storm, 3 hours times the rate, plus after she was out of the dust storm, 4 hours times that rate plus 30, and that should equal 295 miles. So we have 3x plus 4x plus 120 equals 295. Add like terms, you get 7x plus 120 equals 295. 7x equals 175. So x is equal to 25 miles per hour. That was her speed during the dust storm. Just one more to go, and then we will be done with this video and be working on these word problems for 2 days. The last one is a commission problem. It says Sonia is selling her house through a real estate agent who charges a 6% commission, so 6% of the selling price. What should be the selling price so that Sonia can get $84,600? So if we look at this, we have the selling price minus the realtor's commission will be equal to Sonia's share. We know that we are looking for the selling price, so let x equal the selling price. So the selling price is x. Remember, the commission is 6% of the selling price. So 6% is 0.06. The selling price is x. And that will equal Sonia's share, which is $84,600. When you combine like terms, you get 0.94x is equal to 84,600 divided by 0.9. And the selling price, x, is $90,000. Okay? Thanks for watching the video. Hope it wasn't too terrible. Remember to bring your books if you want to use your own book, because we will be working for the next 2 days on the word problems listed in the packet. Have a nice evening. I'll see you tomorrow.